This video is on alkenes, what they are, how to name them, and how to draw them. So alkenes are organic compounds that contain at least one double bond. If they have only one, their formula would be CnH2n, meaning however many carbons you have, your hydrogens will be double that. So the simplest two would be ethene and propene with 2 carbons and 3 carbons and one double bond in each. Their common names are ethylene instead of ethene and propylene instead of propene because ethene and propene are slightly awkward to say. They're named in the same way as alkanes, but the ending instead of being ane is ene. The location of the double bond is indicated with a number, and your number of double bonds is indicated with the prefix. For example, if you have 2 double bonds, that would be diene in the middle there instead of en, just ene. If you had 3, it would be triene. You're not going to see this that often, but you might come across it. So when it comes to naming alkenes, you determine your longest chain that has the double bond between the carbons. So the parent chain, your longest chain, you have to count it with the double bond in it. So even though you may have a longer chain of carbons total, if that longest chain doesn't contain your double bond, it is not your parent chain. You number the carbons so that your double bond would have the lowest number. I always kind of think of the bonds as being numbered more than just the carbons. So location of your double bond is more important in terms of being the lowest number than your branches. All right, so let's do a couple examples of drawing. So if I have 1 butene here, this means bute means I have 4 carbons. Ene means I have a double bond. And that means that double bond is in the first spot. So I'm going to draw my 4 carbons. 1, 2, 3, 4. And I always just start with single bonds. And now I'm going to add in my double bond. It's at the first site. It could be here or it could be on the opposite side. Doesn't matter, right? Because you could just flip it around, look at it from the other side. And now I'm just going to add in my hydrogens. So if I do a full structure, it'll look like this. This carbon would have 1. This one would have 2. Oops. And this N1 would have 3. If I did a condensed, it would be CH2, double bond to CH, and then CH2, CH3. All right, so what about this one? We got a little more involved with this one. All right, so hapt, so my parent chain has 7 carbons. My double bond is at the second spot. Okay, I'm going to start there before I then look at what my substituents are. So 1, 2, 3, 4, 5, 6, 7. All right, second site, so 2 in. I usually just go left to right, so there's my double bond. All right, so now I have methyl groups. I have 2 of them at the 2 and the 5 site. So if I put my double bond here, that means my carbons are starting to be numbered right here. This has to be my 1 carbon. So my methyl group, one of my methyl groups will be off the second carbon here. So that would be here. So here's my CH3 group. And it says my other one's off the 5th. So this would be 1, 2, 3, 4, 5. Top or bottom doesn't matter here because we've got full rotation around a single bond. So I'll draw it here. And I'm going to add in my other H's. So I'm just going to do a condensed. So CH3 here. This carbon has 4 bonds already. This one has 3. So I've got 1 H here. Got 2 H's here. Got 1 H here. 2 here. And 3 here. All right, so now let's do some naming. All right, so this first one here. Okay, my longest chain is going to be, let's see, I just have to have my double bond in it. So it kind of doesn't matter where I start, because if I go here, oops, right here, path, if I split either way here, it's the same. So let's say I go to here. So my parent chain is 4 carbons. Okay, I've got my double bond. No matter which end you start on, my double bond is going to be at the second site. So here's my double bond is at this 2. So we'll put this here. All right, I've got 1 branch here, 1 substituent, and that's a methyl group. And I'm going to start numbering on this end because then my substituent also has the lowest number because it doesn't matter for my double bond. That's a 2 either way. So we start with our substituent. It's a methyl group on the second carbon, so 2-methyl. Remember, dashes go between numbers and letters. And then I'm going to say where my double bond is. 2, it's at the 2 site. and I've got 4 carbons long, so it's bute, and it has the double bond, so ene. So you're kind of doing a little code work. You're decoding here. What does each part tell you? Okay, the next one, you have it drawn in your packet, and I'm going to have you cross out the one you have drawn, and I would like you to draw this one instead. So I'm going to do CH2 double bond to a CH, and then to a CH, and then CH2, CH2, CH3, and this third one I'm going to put this. Okay, so draw this one instead. Okay, longest chain, parent chain first. It's got to contain my double bond. So it's going to be this whole thing right here. This is my parent chain. All right, even though it's the same number of carbons, if I go up this way, I have to contain my double bond. So this way right here. So my double bond is at the first site right here. And then we have a group right here. So this is an ethyl group because it has 2 carbons. And it's off the, if I number my carbons, it's off the 1, 2, 3rd carbon. Okay, and I've got a total of 7 carbons in this. All right, so we're going to start with our group. We've got an ethyl group off the 3rd carbon, so I've got 3 ethyl. Okay, then I have my double bond is at the 1 site. Oops, and this is 6, not 7, sorry. So hex for 6. And the double bond makes it ene. Okay, so now there's one more piece to alkenes, and that's they can have what's called geometric isomers. We've talked about structural isomers, where you can bond them different ways. Geometric isomers are because around a double bond, you don't have any rotation. You've built these with your model kit. You know you can't twist them around. So we have what we call cis and trans isomers. These are geometric isomers. Cis means same, and trans means opposite or different. Okay, so what we're looking at here with these two, these X's are whatever other group. It could be more carbons or chlorines or hydroxides, anything like that. But if you notice in this first one, they're both on the upper part of the carbons. So this is a cis isomer. This next one, if you notice, we've got X up here and down here. One's up, one's down. This is our trans isomer. So they have the same empirical molecular formula, but it's how they're put together that's different. And they actually have very different properties and will react very differently, which we'll get into more when we get to reactions of organic molecules. Okay, so let's name this one right here. Actually, let's not. This isn't in your packet. Let's do this one. This is the first one in your packet. So I'm going to look for my parent chain first. My parent chain has 4 carbons, right? I don't have any branches. Okay, here are my carbons right here. Okay, 4 of them. All right, my double bond is off the second, right? The second spot. And what I need to look at with this double bond is the fact that my 2 carbons off of them, so this carbon and this carbon, are in the same direction. They're both on the top. So the name of this will be cis, because they're the same. My double bond is at 2, and I have 4 carbons. So butene. So now let's look at the next one you have. Okay, same thing in terms of 4 carbons. The double bond is still in the second spot. But now my groups are top and bottom. Okay, so I hope you can see the difference. Same number of carbons, H is all of that. Like if I just gave you the empirical formula, you would not be able to know which one it was. But if I give you the name, you should be able to. This second one here is trans 2-butene. Okay, so now let's draw one. Okay, draw cis-2-pentene. So there's a couple ways you can draw this. Let's start this way. If I do my carbons, 1, 2, 3, 4, 5 carbons. Okay, ene means I have a double bond right here at the second. So let's put that here. And then cis, so around that, my carbon branches, or not branches, but my carbons come off in the same direction. So one way of doing this would be like if I put the H's on here, both in the same spot. So it's not drawn, but a better way to do this would be like if I had this, to do them like this, like we saw in the upper ones. And then I would have off of that, right, this would be H2, H3, CH3. So here's where it would be best to write CH3 here, and then CH2, CH3, like this. Okay, you could do it either way, but I think this second way is a little more clear. So alkenes, very similar to alkanes, but now you're labeling where the double bond is, and then you've got your geometric cis and trans isomers. One last thing, and that is if you look at your learning check, number 3 says draw cyclopropane. All right, that should not say cyclopropane. That should say cyclopropene. All right.